All right, so what I've said so far applies to any kind of equation. But for now, let's consider these equations here, which we call linear equations. So these are linear equations in one variable. So you have a times x plus b equal to c. A, b, and c here are numbers, real numbers, that is. A cannot be 0. If it was, the variable wouldn't be there, and there wouldn't be much for us to do. So that's what this is by definition. And let me just say this, the way you actually solve these, you perform any of those manipulations, you want to get something that's equivalent to this. Right? This is actually a linear equation. You could take A to be 1, B to be 0, and C to be this D, whatever it is. But you could see from here that there's only one solution to this equation, whatever this number D is. So the whole point is, with these linear equations, you manipulate it until you get something like this, x equals some number, some constant, and then you can easily get that solution. So linear equations in one variable only have one solution, which is nice. Later on when we get to quadratic equations, where the left side here is a polynomial of degree 2, then you could have two solutions. But these equations, linear equations in one variable, they only have one solution. Okay. So here's an example. Let us actually solve this equation. I mean, we saw the solution already, but let's find that solution using the manipulations from before. Okay, so what did we do? The whole idea is we want to get x all alone on one side. You want to isolate x. I think that's what people say. You want to isolate x somehow. Okay, so that's what I'm doing here, right? I'm subtracting 1 from both sides, as you can see. We have 2x equals 1. Then we divide both sides by 2, right? Because we have 2x equals 1, but we want x. So we divide, we get x is a half. So in other words, the only solution to this equation is a half, right? So this is what we got, this equation. And it's easy to see that this has only 1/2 as a solution. So that's our solution set. These curly braces is what people use to denote a set. Okay? I mean, I'm not going to get too crazy with the notation on a quiz or exam, but I just wanted to point that out, though. Okay, that's good. So in this case, again, we only have one solution. All right, so that's one example. Here's another one. Notice here, it does not look like at first we have a linear equation. However, we can manipulate it so we have a linear equation in one variable. In other words, this is equivalent to a linear equation. So this is actually a linear equation, I should say. All right. So anyway, how do we solve this? Well, again, we want to manipulate it, right? It may not be so obvious at first what the solution is. So what do? We're going to manipulate it. And again, you want to try and get x all alone. That's the whole point. Okay, so what did I do here? Well, you don't have to perform in this order, but this is what I did. So I subtracted 7x from both sides. So we get -5 times x plus 3 equals 1. Now, as you can see, we actually do have ax plus b equals c. Okay, so we do have a linear, well, yeah, so we have this now. So now we have to solve this. So what I want people to do now is just take a few minutes to try and solve this. I mean, it shouldn't be that bad, just take like 3 or 4 minutes. Let me just pause the recording. Hold on, oh jeez. I'll share it again, don't worry.